So let me start. Thanks a lot, Zongi. Thanks, Professor Wong, and thank you all for coming. Let me share screen, and I hope you can see. All right. So I'm going to this evening or this morning for you, and a good morning to everybody in Taiwan. I will be the appetizer. Okay, I'll be the first course because after me, my outstanding colleagues, Professor Helen Lee and Professor Neil Gong, will talk about their research. So I will introduce you to Duke ECE and about our research, about our students, about our PhD program, master's program, and so on. So Duke University, I just want to tell you a little bit about who we are and where we are. So we are very proud to be ranked as one of the best in the world. So if you look at US University rankings, US News and World Report, overall we are number 8, 18 in World University rankings of Times Higher Education, 25 in the Shanghai ranking. We are small, and we are small intentionally. We like to stay small because then we can give a very unique experience to our students. 15,000 students altogether, 6,500 undergrads, and about 8,500 students who are in the graduate programs, the medical school and law school, and so on. We have 10 schools and colleges campus-wide, and we are located in Durham, North Carolina. So in this US map, you will see that we are in the southeastern part of the US right here, rated one of the America's best places to live in terms of the quality of life, cost of living, the weather, and so on. We are also a very international university. We have a presence in China, in Kunshan near Shanghai. We have a campus, and we also have a partnership with the National University of Singapore Medical School. Okay. So the Pratt School of Engineering, which is one of the 10 schools and where ECE belongs, is one of the fastest rising of the top engineering schools. If you look at research funding per faculty, we are in the top 10 in the US. Last year, we had nearly $100 million in research expenditures for the entire school. Our community is very dynamic. We have over 1,000 graduate students, 1,200 undergraduate students, 138 faculty. So you can see the ratio of faculty to students is very high, so that we have very good faculty-student interactions. We have a very good alumni base. They are very actively involved in all our programs. 13,000 plus Pratt engineering alumni and over 160,000 alumni from the university wide. In the Pratt School of Engineering, we have 4 departments: biomedical engineering, which is all ranked very high, civil environmental engineering, and ECE, and mechanical engineering. And then we have a master's program in engineering management. The culture is very welcoming, very open, very interdisciplinary, and very collaborative. So I'll just walk you through the campus. This is Duke. This is the view of our chapel. And in the fall season, it looks very, very beautiful. This is the East Campus where most of our first year undergraduates live. Our humanities, political science, history, these programs are in the East Campus. It has a Georgian brick style architecture. And this is the West Campus. It has got a stone, Gothic stone architecture. This is the Duke Chapel from the side. Engineering is here, so is the medical school, and many of the basic sciences are in the West Campus. So let me play you a movie. This will tell you a bit about Duke. Okay, so this is just a short movie on Duke, and you can see that we are a very well-rounded institution. We not only do scholarly research and teaching, we also have sports and athletics and cultural things, dance, music, and so on. Now let's look at the ECE program. In ECE, we think we are world-class. We have amazing faculty, amazing students. Mentorship starts from the very first day for our students. If you look at the rankings in the AI machine learning research area, there is a ranking based on Neurips publication where we are number 6 among US universities. Computer engineering ranking based on academic analytics. This is what Professor Ho was talking about. These rankings are based on productivity per faculty. So this is not biased by the size of the program. If you look at MIT, Stanford, they're massive. So as a result, they have big numbers. We are much smaller. So if you look at per faculty member, we are number one in computer engineering, which is amazing. And in electrical engineering, we are number five. So this basically shows you that we are a very quality department, and our research is at the very top. You will get a lot more information about our PhD program with this link. You can follow this link, and you will get a lot more information. Our research strengths are in several key areas. Of course, we have strengths in other areas too, but we have to showcase the areas where we are especially strong, internationally famous. So quantum computing is where we are very well established. We have several internationally top faculty. We have huge research programs. Metamaterials. This is a research area where people are looking at electromagnetics and sensing, and basically you might have seen a lot of popular articles about the cloak of invisibility. So you have a material that can bend light. So if you wear a cloak made of that material, you become invisible. That's pretty cool. And then we have AI machine learning, which you will hear about this morning in the talks by Professor Lee and Professor Gong, who are two of our superstar faculty in this area. We have strengths in nanoelectronic materials and devices, sensing images, and trustworthy computing that looks at fault tolerance and reliability, security, and so on. If you look at our research funding in fiscal year 2020, we had $34 million in new research grants, which is a lot of money considering the small size of ECE. We have about 40 tenure track primary faculty over all ranks, so assistant professor, associate, and full professors. Plus, we have other faculty who teach, who don't really do much research, but they're more for teaching. We have 20 IEEE fellows. This is a pretty sizable fraction, considering the fact that we only have about 40 tenure track faculty, and many of them are very young and very new. So if you look at our senior faculty, most of them are IEEE fellows. We have 4 members of the NAE. This is the highest recognition that anybody in engineering can get, and this is the National Academy of Engineering. We have 4 members there. And I already talked about our rankings in research productivity based on academic analytics, number 1 and number 5 or 6, it varies in E. So the faculty over the years has grown. So we started off very small. I joined Duke in 1998. And at that time, we were only 18 faculty. I was number 18. Since then, we have grown, and this number you see is including those who teach. So this is not just the tenure track faculty. We also have a lot of faculty who are jointly appointed. So we count them as fractions. So we have professors who are both in ECE and CS, ECE and physics, ECE and math, and so on. So we take all of them all together, and then we get these numbers. So essentially what you're seeing is a very nice growth over the years, and we will continue to grow as we expand our research. PhD enrollment has also grown. It's consistent with our faculty growth. So we had about 100 PhD students a few years ago, about 10 years ago, and now we are 186. So this is actually a few years old. So it's actually crossed 200 since I actually made this slide. What makes Duke ECE special? So you might be wondering, right, what is unique about ECE? I would say a very positive relationship between professors and grad students. So our professors really care for our students. My grad students, they come to my home, they know my family, they know my kids, and then we look after, our faculty really care for them, for their growth. We provide them internships and job opportunities. So it's a very personalized touch that we have. We have very highly productive professors and students. They win all kinds of awards and prizes, and we offer full funding for our PhD students. So you don't have to pay anything to get a PhD at Duke. We pay for stipend and tuition and health insurance and everything. External recognition, our students win awards, best thesis awards, best paper awards, which is really wonderful for them. And the environment is very diverse. So you will be in a community with scholars from all over the world, and that in itself is an education. So having students from Asia, East Asia, and South Asia, from India, from Eastern Europe, and Western Europe, and South America, and Mexico, and US, and Turkey. Having that environment is very enriching, and people learn a lot by working in collaboration with people from all over the world. In fact, my experience is that in my own research, I have collaborated very enthusiastically with partners and colleagues from everywhere, from Taiwan, from China, from Germany, from Japan, and I found that we can solve the world's most difficult problems by attacking them from different points of view. So if you have a training in Taiwan, maybe you think of a problem in a very different way compared to somebody who was trained in Europe, right? So this is very important for solving the really hard problems in research. And also, we give very strong support, not just financial support. We have staff who will be there to help with paperwork. If you need to change your plans, you need to think of something outside the university. We have staff who can help with that. And job placement. Everybody gets a very good job. In my group, grad students are getting 4 or 5 offers from their third year. It's very hard to actually hold them back because they're getting such good job offers. So some actually finish the PhD while they are working outside, working full time. We provide support for conference travel. So we give $1,000 per year to every PhD student to present a paper at a conference, and then they can get us some more money from the graduate school. And here's a list of places where they have traveled in the past year or two within the US, of course, all over the country, but also internationally. Our students have presented papers in Scotland, Canada, Brazil, Austria, Switzerland. You can find these very interesting places on this map. Employments after our students graduate, they're getting great jobs in some of the top companies, also the top universities. So this is a pie chart we made based on where they go. So of course there is a large part in gray. We couldn't find out where they went, but I'm sure that these guys are all well placed. But you can see many go to academia. This is the part in red. Many go to industry. Some go to work in government. And the kind of employers are universities like Johns Hopkins and Michigan, companies like Facebook, Microsoft, and labs as well. So you can see there is a wide mix of places where they go for jobs. Um, Now let me talk about our master's program. So we have two kinds of graduate programs, PhD and master's. And the PhD program if you want a shorter experience, maybe 2 years, and then you want to work in industry, or you can transition to our PhD program, then you can consider the master's program as well. Top 5 reasons to join our master's program. I would say they are excellence, very, very top quality, compelling curriculum, a lot of great courses to take, projects to work on, career outcomes, you get great jobs, student support and programs, and of course, the university and where we are located. So faculty advisor, so every master's student is assigned a faculty advisor. So even though the master's student is not doing research, but we still would like to match that student with an advisor. And advisor assignment is done soon after the student accepts the offer. And if this is, if you have an advisor in mind you really want to work with, you can make the request, and we'll do our best to keep that request based on availability, of course, because some advisors are so popular that everybody wants them, and we can't have that person work with every student. So we try to balance the load as well. But if you find that afterwards the match is not very good, you think that this advisor is not the best fit for you, then we can also make that change at any time. Let's look at the curriculum. So we have a master's program called Masters in Engineering, or MEng. This is one of the two main master's programs we offer. And in MEng, we basically have a focus on building up your technical and business leadership expertise. So people who are looking to work in industry, follow the managerial track, for them, this is the ideal option. So there are two classes which are on the management side. You can see here the MEng 540, MEng 570. They are about business and management. But we have 3 courses that are ECE concentration electives that students must take. They have to take 2 other graduate technical electives. These are courses that are more in the science and engineering fields. And then there could be 3 other electives that could be even outside engineering or outside sciences. And then there is a project that they have to do, an internship or a project as part of the MEnt experience. Then we have the the MS program, which is the more popular program for ECE. And this is intended to give you a solid foundation of rigorous training and research. And with the MS, you can have different pathways. You can work in industry, but you will be focused more on the side of research, or you can go and do a PhD. We have three pathways. One is a coursework pathway where you take more courses. And in fact, 85% of our students actually do this. You have four graduate EC courses. You have two technical electives, which are could be other engineering or science type classes. You have four other classes that are approved by ECE, and some of them are not in sciences even. They could be outside sciences. And then you have a poster and a final exam. The second path, which is getting more and more popular each year, is a project option where students can substitute one of the, they can substitute one of the classes with a project, which is shown here in blue. And basically they will work with the professor for one semester or 2 semesters and do some research and get some experience of research. This is a great pathway if you are looking to transition to a PhD program because you get to know a professor, you get to know about research. And then we have a third option, which is not very common right now, is to do a thesis. This is an option that is ideal for students who really like research and they want to write a full thesis. So this would count as 2 semesters. Sometimes it takes one more semester, but you go more into research and and then you write a master's thesis. Okay. Specialization tracks. So you can choose what kind of areas you want to specialize in. So we have software, which focuses more on software engineering, building large software packages. Hardware, they're more about architectures and chip design. Machine learning is now a very popular concentration track. You learn about big data, AI, ML, the theory and applications and algorithms and building an AI system. And nanoelectronics, you learn about very tiny devices, transistors, and so on. And then quantum is a new track we have just created because of our strength in research in quantum. We have now a specialization track in the master's program where our students can learn about quantum physics, engineering, computing, and have some experience with industrial partners. So usually, it's a 2-year experience. So the first year, the courses are the core courses. These are often mandated based on the track. The courses are you have to take those courses as foundational. And then year 2, you can choose more advanced classes based on your interests, and you can do an internship in between. Okay, so scholarships. So the PhD program, as I said, is entirely funded. You don't have to pay anything. The master's program is not funded by us. It's you have to pay yourself. But we have some scholarships that are available for the best students. It doesn't pay for the entire master's program, but it's a big help. So here's a range of numbers. You can get this much money for your master's studies based on merit. So this you can get after you arrive based on your first semester courses and your grades and your participation in various activities in ECE. Internships are a very important part of our master's program. So most of our students will do a summer internship. There are several advantages. You learn about skills that you don't get in the university. You get exposure to problems that are real life problems and you don't see them in your courses. You make friends and in networking, you make tremendous contacts in companies. So once you are graduating, you can get good job offers and you make money because these internships pay really well. In the past couple of years, we have had our students do internships at various companies listed here, different types, financial and tech, Apple, Facebook, LinkedIn, Microsoft, SpaceX, some of the cool companies out there. Okay, and some of these internships have been even international. Students have done internships in US, but Europe and China and so on. Just a quick look at the location of some of the internship companies. So you can see that we are in southeastern US. So this is where we are. SAS is right next to us. It's it's not far from Duke. Philips in the Northeast, TI in Texas, and then SpaceX in Southern California, and in the Bay Area, Umbrella, Synopsys, Facebook, Apple, and so on. Microsoft in the Seattle area. So the whole range of opportunities out there. Career outcomes. So we have had our students, work in the private sector. Most of them after masters. You can see this. That's the pie chart here. Some go for PhD. In fact, in my group, I've had over the years 6 students who did PhD with me who came from the master's program. So they come as master's students. They take classes. They get to know the faculty, and then they can transition into the PhD program. A few unknowns, like we don't have information on where they went, but then some went to work in government as well. So the salary numbers are shown here. So again, these numbers keep getting better every year. So these are the mean salary numbers, and then you see the percentile, 25th and 75th percentile. So this is not the only benefit, because as you know, if you work in tech companies, you get a lot of other perks. You get a bonus at the end of the year, and the bonus can easily be a 1/4 or 1/3 of your salary. And then you get to get some stock options. So after a few years, you are vested in the stock, so you can gain a lot more, income in that way. Again, the kind of companies where our master students go after they graduate, a whole list of them: Google and Samsung and Amazon and Oracle, and so on. So it's a very nice list of these companies. So finally, I want to talk about the location. So we are in North Carolina and in Durham. It's called the Bull City. So several surveys have mentioned that this is one of the top 10 places to live in the US. Number one best mid-sized city for jobs. The number one most tolerant city. So we are very welcoming. We are very open to all cultures, all countries, all nationalities, all races. So very open city, one of the top 10 tech towns. 100 best communities for young people. So a lot of things here that are really, really good. We also have very good food, but maybe not as good as Taiwan, because I know the food in Taiwan is excellent. But this is also very good food here. And if you look at some of the surveys and some of the rankings, so overall ranking comparing to other states, North Carolina is number 5. So this ranking is based on quality of life, tech and innovation and education. So we are number 5. We are ranked better than New York State, California, Massachusetts, right? So really nice. And you can see here the bar chart talks about different metrics and the various states. So North Carolina is in blue, so we rank very high in quality of life, in tech and innovation, and also in education. If you look at the cost of living and you normalize it, you will find that compared to Manhattan, we are much cheaper. So the $30,000 that a PhD student would get here as an annual stipend, to have the same quality of life in Manhattan, in New York, you're gonna need $75,000 because New York is so expensive. And you will need $58,000 in San Francisco, again, because it is so expensive. So you can have a very good quality of life at a very good university for much less cost by being at Duke. And finally, my last slide is to show you our graduate programs. So, please uh, consider applying to Duke for PhD and master. So you have here the Director of Graduate Studies, Professor Aaron Franklin. Angela Chan is our PhD program coordinator. Professor Martin Brook is the Director of Master Studies, and Tony Strimple is our Master's Program Coordinator, and Angela DiMaio does the academic logistics coordination. For PhD studies, the best path is to contact the faculty member on your own. So if you want to work in a certain research area and you really like a certain faculty member, you like that person's research, you can just contact that person, because our PhD admissions are based on faculty recommendations. So if you want to be admitted for the PhD program, there has to be a faculty member who is going to recommend you. And for the masters, you don't need to do that. Masters admissions are done by a formula that looks at the application in a holistic manner. So we look at not only the GRE and TOEFL, but also the the university you come from, and since you're from NTHU, and we know it's a top university internationally, so we would love to have more applicants from NTHU. We look at your GPA recommendations and so on. I think that is my. I have. This is the final slide. So this is the website. So you can learn more about our graduate programs by following this link. So with that, I end my presentation. Thanks a lot, and I hope to see lots and lots of applications from NTHU. Thank you very much.